Okay, so we are now going to look at example number 5 on page 373, I'm sorry. 373. So let's go and look at this. So this is going to be our holy grail today. We can figure this out. If we can figure this one out, okay, consider yourself a job well done today. Tracking a moose population. So we're going to track a moose population in 1985 and 87. Michigan Department of Natural Resources airlifted 61 moose from Algonquin Park, Ontario, to Marquette County in the Upper Peninsula. Huh? I guess so. It was originally hoped that the population P would reach a carrying capacity in about 25 years with a growth rate of such. What? That. Okay, so we have dP dt is equal to 0.00. Is there one more zero there? One more zero. 3p and 1,000 minus p. Okay. So we're going to try to solve this. Okay? This is what we're going to do. Today, we're going to try to solve this equation. Okay? This is a separable differential equation because you can separate because there's no t's here, right? So you can move all these down underneath here and move the dt over here, and I just separated it. I'm good to go. Right? I have separated it. So in other words, I'm going to get to dp 0, 0.
Instead of division.
I'm trying to find p into some function that entails t. Okay, that's what I'm trying to do. So this is what I'm trying to solve. Okay? So I can, well, let's go ahead and keep this guy over on this side. I'm going to get 0.0003 dt. Okay, so what do I have here? I have a rational, or I have x and I have another x type of thing here, right? So I should be able to separate this in order to do the integration, because this is what I'm going to end up doing, right? I'm going to end up doing this, right? This is what I'm trying to do, right? So I'm going to go, let's go ahead and work on this guy first, okay? So let's go ahead and just work on this. So over here, I'm going to have P1000 dP, which is the same as, and I want this in a form that looks like right, because then I can do something with it, right? Okay, so I have to solve for A and B, just like we did before, right? And cross multiply, I get 1,000 A's minus AP plus BP is equal to what? What does it equal? 1, right? So how many P's do I have? I'm going to have no P's, correct?
Yeah, that first.
Right? And then is equal to what? 1? Same thing, really, actually. Right? Because A and B have to be the same. Becomes 0. So I'm going to get, that was pretty quick. Right there.
Minus A plus B.
Over here, right? If I move the A over, B is equal to A, right? Right? So let's go ahead and pull out the 0.001 and make this 1 over P. 1,000 minus P over 1 dP. And this is going to be equal to 0.0003 dt was it? Right? So I'm going to go ahead and multiply everything by 1,000, which gives me, actually, let's go ahead and do this out. So I'm going to get and this is going to be equal to 0.3. Is it 0.3?
Yeah.
1, 2, 3, 1, 2, 3, yeah, 0.3 dt. So a lot easier. We're a lot closer to where we want to be, right? Okay, we're getting really close here now. Okay. So what is this? What is this? Plus c? Well, whatever. Okay, so what do we get over here? 0.03 t plus c, right? I'm going to just combine those c's together, right? So let's verify this. If I take the derivative, what do I get? 1 over p, right? If I take the derivative of this, what do I get?
1.
Really?
Really?
You sure?
No. Oh.
No,
Look
all
at-
we did the chain rule.
Oh!
The chain rule.
The guy who was sleeping finally wakes up and makes the best thing. This is great. So, okay, so exactly, this is going to be negative. So the chain rule, right? Because it's a minus p inside here. So once you take the derivative of this, you get this guy, but then you have to take the derivative of that inside there again, and that's where that negative comes from.
Oh, so it's negative.
Okay, so that's a negative there. Good catch. Okay, so here we go. You have to rest
Hard.
So, natural log of p over. Can we do this?
This
You can do that, right?
is negative.
No, because that's why it's underneath, right? Okay, now over here, I still have is equal to, right? I need to solve for, I'm trying to solve for p in some sort of terms of t, correct? So I think I get rid of the natural log now, right?
Aha.
Right? So over here I have p
That looks familiar.
times e to the c, right? Basically. Correct? I'm gonna flip it over. Or do I want to flip it over? It doesn't really matter whether I do or not. Because I need to solve, well, let's go ahead and put it, let's go ahead and solve it. Let's go ahead and solve completely. So I'm gonna flip it over. I get 1,000 minus p over p. Right? I flip both sides over. This is basically 1,000 I divided both sides by p. All right. Okay. Move the 1 over. This is what I get. Right? Flip it back over.
Double flip.
Wait, why bother flipping it?
Oh,
Because this becomes a lot easier.
Oh, it's just
yeah.
Right? And I got rid of that 1 over there by moving it over. That's what that accomplished. I'm going to, so it's e to the minus c. Right?
Oh, you can't just make those back in positive.
So this is what the logistic function looks like. And this is where that form comes from. Okay, so if you consider this just being a constant, this isn't a constant, right? This is just a constant, so I'm going to call this just constant like that. Where do I find this constant? It's the initial condition, right? How many moose was first airlifted there? 61. So when t is equal to 0, right? I must have had 61, right? My initial population was 61.
Oh,
1
gosh.
plus c.
Oh.
That's a big number.
Actually,
Too big.
actually, it's pretty small.
I don't want to think of that.
Flip it.
I don't want
Wait, where did it? Oh, geez, but it just goes away.
So I take this, flip it over,
to.
multiply it by 1,000. Move the 1 over. Right?
Yeah.
Whatever that number is your initial, that is your C. So again, this is not easy. This is not easy. And I am not going to ask you to do this on the test. Okay?
What is the?
But you do need to know where this all came from. Okay, but by doing this together, hopefully that kind of puts you in the point where actually if the push came to shove, you know that you have it in you to actually to try to do this. We walked it through, right? It is possible, correct? And if not for the brilliant negative there, we would not have gotten there. Okay. So if you go to page 374, top of page 374. If you look there, you can see on the from the second line to the third line. Okay, that is that negative there. Okay, in front of the natural log, 1,000 minus p is the negative. That's the chain rule negative. That's where that came from. Okay, all right. So remember that.
Just
Then follow through. Look at the book, and see if you follow through. You should go ahead and read through it after that. Again, we know that the E sub c, this guy here, E of negative c, was determined by our initial condition, right? The initial population. Our initial population. Okay, so I go to page 374 in the middle green box, the general logistic function formula. Okay. P is equal to m over 1 plus a e to the negative mkt. That's a lot of letters, okay? Okay, so, but m is the easiest one to carry capacity, right? And then k determines how quickly it goes up. Okay, so in other words, is the graph going to look like this, or is the graph going to look like this? Okay, that's what the k determines for you. Okay, and the a is the number associated with, again, the initial condition, right? That's how you find that a thing there. Okay, yeah. So it's the,
Like the line.
where does it start from, right? Okay. We are done. Let's go to example number 4. Let's quickly read through example number 4. The growth rate of a population P of bears in a newly established wild reserve is modeled by a difference equation, blah, 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 where T is measured in years. What is the carrying capacity of these bears? Just reading that, what do you think it's going to be?
100.
Yep, looks like it's 100 to me, doesn't it? Right? B, what is the bear population when the population is growing the fastest? Ooh, do you remember this question? This question I put this question on your honors pre-calc test. It's right in the middle, right? It's right in the middle because if you look at the P 100 minus P, right? You have your 100 minus P times P, right? That is basically your growth curve, right? That sets the growth rate, right? That's the rate, right? Because it's dp dt, correct? When is that going to be the highest? Well, this equation is going to look like what? 0 and 100, right? It's a parabola, so it obviously is going to be right in the middle right there, right? Well, P is 50, right? So yeah, so when it's half a carrying capacity, right? 50 bears. C, what is the rate of change of the population when it is growing the fastest? What is the rate of change? Yep, just go ahead and plug it in. You get 0.008 times 50 times 50. And you do that, you get 20 bears per year. That's a lot of bears. Why doesn't the population of bears grow exponentially? Why is it logistic rather than exponential? Why is there a pack capacity?
Space or food or.
Correct. You're limited by the space. Well, not the space, but the resources.
And they die.
But I mean, but that's
Bears die.
bears die. Well, they die. Yeah. But also, but you understand what I'm saying, right? Okay, we're good.
Bears die. Poor bears.